Now it's clear? Okay. Okay, then we have discussed about Gauss theorem. This Gauss theorem, what we could find from volume integral to surface integral. From surface integral to volume integral also we can do. So this is what is about your second chapter. Now we need to go to the third chapter, that is your linear momentum and collisions. How this takes place. Yeah. This is your topics, linear momentum and collisions. So what is collision? What is linear momentum? We need to know. Okay, I'll explain about that, how this takes place. So linear momentum is nothing but the vector quantity. So we are keep on talking about vector, right? So we need to talk about vector quantity. So it is
Yes,
nothing. Yeah, tell me.
nothing, madam, nothing.
Yeah, we need to talk about linear momentum and collision. So our main heading is about linear momentum and collision. So now till now we have studied in your unit 1 and unit 2 about the about the vector, right? What is a vector? So we know what is a scalar, what is a vector, but we always need to find out how this vector is helping to find out the fluxes. Okay, so we need to know what is linear momentum. So momentum is nothing but what which travels. Moment. If there is no momentum, if there is no movement, the particles, whatever it is there, it will be there in the own place. There will be no disturbance and distraction. If you are moving some, if you are giving some external force, then only any any material it starts moving. So that is what is momentum. So we need to talk about linear momentum is nothing but a vector quantity and defined as a product of the mass of an object. To define the product of the mass of an object. So objects are nothing but what can be the object? It can be anything. Okay, that m and its velocity v. We are going to find the mass and velocity. Okay, here we can call it as P is applied for the express and it is used as a momentum for the short. So here the body's momentum is always in the same direction as is the velocity vector. For example, if a bicycle is there or a car is there, any object is there. So what happens if you are giving acceleration? How we are giving the direction? It starts moving in that route. It does not go backward, no? If you're giving the acceleration to go for front, the velocity and the mass will be going towards in that forward direction. It does not go. If you are giving reverse, it goes in the reverse. If not, it goes in the forward direction. How we are giving the momentum? According to that only it travels. You're understanding the concept?
Yes, madam.
Yeah, others join. How many members are joined? Yeah, 9. Okay. So that is what is about the linear momentum. So we need to know the main why we are studying. So next what we have studied. First we have studied about vectors and scalars. Next we have studied about the how these fluxes are going to help. How this vector having both magnitude and direction. Please mute. No, it is. I'm getting some disturbance. Yeah. Okay, so how the direction is taking place? We could find linear, surface, and volume. So bulk we have taken. So we have done the integration part. We are able to find the bulk of the linear, surface, or volume integration for the fluxes, means the direction, how the direction is taking place. Now we are going a little further to find out the linear momentum and collision. So now we understood how the linear momentum takes place. Linear momentum is nothing but moving from one place to another place. Okay. So why we call it as linear? It is nothing but we are going to find it is a vector quantity and the product of the mass of an object and its velocity v. Okay, it's nothing but an object where it has a body momentum always same in the direction as its velocity vector. So we are going to find the velocity vector and collisions. What is mean by collision? Anybody? can answer what is collision? General word of collision means. Anybody can answer what is collision? Colliding.
Collision
Yeah,
means
please.
दो चीजों का टकराना means when two things collide
Ah,
each other.
yes, exactly. Perfect. Mr. Vinod Kumar, you told the perfect answer. Collision means colliding. Means two particles are colliding with each other. If I'm taking two water molecules, it collides. If I'm taking two gaseous molecules, it collides. Okay. So if I'm taking the molecules which can collide. Okay. So that is what is about the collision. So we are talking in this unit 3 about linear momentum and collision. How this both takes place. Okay. So here linear momentum of a particle, of a system of a particle, conservation of linear momentum, impact parameters, collision cross section application to atomic collision. Okay. This is our topics which we need to discuss today. So we are going to complete the unit 3 completely today. Yesterday, class was there, but you people didn't give me any message or something. I don't know. I could not check it out. So please, somebody take some responsible because I have another works also. If I have class, just remind me. Sunday I know, but second Sunday I could not know. I didn't check it. So please take some initiation and try to give a message or give me a call. So I'll definitely
Madam,
take the class.
can you share the number so that I can call or message you?
Yeah, I'll share it. I'll message in the group.
Right,
Okay.
madam. Thank you.
Yeah.
Yeah.
Okay, so introduction, what is about? We are going to talk about the conservation of linear momentum and also the term collision cross section. Define the term collision cross section and impact parameters we need to discuss. So let us see the introduction. So as I told you about the introduction about the linear momentum, that is what is being explained. Linear momentum and its conservation. In order to make you understand the concept, it is known that the rate of change of linear momentum of a body represents a force acting on a body, and that the total linear momentum of the system particles is equal to the product of the total mass of the system and the velocity of the center of the mass. So if I'm giving some force to move from one place to the another place. So if a car is traveling, means I have given some external force, that is the acceleration, and I have given some force to move from that place to another place. Okay. A nuclear reaction may takes place whenever an incident particle collides with a target particle. So the nature of collision between nuclear particles can be described by the impact parameters. In defining the impact parameter is nothing but which is causing. Impact means which is the factor which is happening over there, means impact parameter. So impact is nothing but in that place, in that collision, the impact is more. That's why the collision takes place. Okay, we can consider the target particle to be at a rest, but in practice, we cannot define that track of the incident particles or the location of the target particle precisely. It is not possible to isolate the incident particle and the target particle. The study the collision process particularly when the particles involved are atoms and subatomic particles. The collision process has to be dealt within a statistical way. To study nuclear reactions in detail, it is useful to have a quantitative measures of the probability of a given nuclear reaction. So how the nuclear reaction takes place, just they are explaining over here. Okay, the quantity most often employed in the collision cross-section. Let us now study how cross-section of for a nuclear reaction can be estimated and its importance in the understanding of nuclear reaction process. Okay, so let us just they have given an introduction about the linear momentum and collision. So we are going further about the linear momentum of a particle. So particle means it can be anything. Okay, so let us see what is linear momentum of a particle. Means we have a p bar. Particle is p, as I told you. Velocity is v. Okay, which is moving according to the momentum is nothing but mass. Okay, P bar is nothing but a vector. P bar is nothing but particle of the vector is equals to mass of the velocity V bar. So how the particle is moving, that will be equal to the mass and the velocity. That is what is linear momentum of a particle. Understand? So the linear momentum P,
Yes, madam.
yeah, P vector of a particle of a mass m moving with a velocity. How it is moving? With a velocity v bar because we have a direction. That is it's a flux. It will be flowing in one direction. That might be taking in any direction. As I told you in the last previous class, the direction will be in the straight line with an arrow. That might be in any position or any shape. It will be flowing in one direction. So related to an observed in an inertial reference frame is defined as P is nothing but particle. Please remember M is nothing but mass. P is nothing but velocity. So basic P is particle. Without particle means without any object or without any material, there is no momentum. So M is the mass and V is the velocity. So when particle is moving from through that, mass and velocity is also carried. So the linear momentum is a vector quantity. As I told you, its direction is the same as the direction of the velocity of the particles as per Newton's second law. So the force acting on a body of the mass m can be expressed as I told you, when the particle is moving, according to that, mass and velocity will be also moving. That is what is being explained. So that force bar, that is bar is nothing but vector. Okay, I will keep on not repeat. If bar is being given means it is nothing but vector where they have both magnitude as well as direction. Okay, dp bar by dt is nothing but particle. That we can write it as d of m of v bar by dt. That is mass and velocity. That can be written as m of dv bar by dt. That is equals to ma bar. Ma bar is nothing but acceleration. Okay, if the force acting on a body is zero, then the momentum of the body is constant. That is, the linear movement of an isolated particle remains unchanged with the time. Okay, unchanged with the time means what? Does not depend upon the time.
Time.
Yeah. Okay. So linear momentum of a system of a particle. So next one, first we have studied about a momentum of a particle. Now system of a particles we are talking. Okay. So consider a system of n particles. So we are taking, first we have taken for one single particle and we are 10. We are explaining or we are talking. Okay, we are understanding. So now we will talk about the system of particles. Before we have spoke about particle, now we need to talk about particles. So why this has been given explanation to understand how the particles are moving from one place to another place. Why we need to understand this? Because we need to understand how the electrons are traveling from one place to another place. There is a momentum. There is an external force given to that. So the external force is given to a system. What happens? It starts conducting and it travels. Then only we are able to get a current or power, whatever. Okay, so let us talk about number of particles, system of particles. Consider a system of n particles having masses, that is m1, m2, m3, so on, mn. Let us assume that no mass enters or leave the system. So it does not enter or does not leave the system. Okay, hence the total mass m is equals to sigma mi remains constant. I is nothing but we can talk it about I can be anything that might be current. Okay. So for example, if I'm taking a iron sheet, okay, iron sheet, in that iron sheet, so many, what it will be there? Electrons will be there, right? So many electrons are there, it will be ready to conduct. If I'm giving some external force to that, it starts conducting. So if I'm taking a sheet, so let us assume that there will be no mass enters or leaves the system. It does not leave, no. The electrons can't jump out from the iron sheet. It will be there, remain same in that system. Just giving you the best example. So you have to imagine, while I'm explaining, you try to please imagine how the things are working out. Okay. So complete mass M we are taking. and that is sigma mi is nothing but total masses of the system. So remains constant with time. The particles of the system may interact with each other and external force may also act on the system. As I told you, the particles of the system may interact with it. How it interacts? Because one electron, what it does, it starts vibrating and irradiating and hits another electron. And it continuous process happens for that. If I'm taking a one single sheet of iron sheet, if I'm taking, so what happens? Once if I'm giving some external force to that iron rod, okay, let us take a iron rod, not to talk about the sheet. Sheet means it becomes a huge. So let us talk about an iron rod. So iron rod, the electrons are being placed one by one. So it is ready to conduct. Okay. So what happens when the particle of the system may interact with each other and external force may also act on the system. So normally it will be conducting if we are giving some external force. If not, because of the heat also it can start conducting. You can touch the iron rod if it is placed in the sun. You can feel it the more hot. You can feel it, right? You can't touch the iron rod if it's in the sun because it starts conducting. The energy will be produced more. Even if you're not giving some external force, still it can conduct. Yes, Vinod, you have any doubt?
No, madam.
Okay. Fine. Under these conditions, each particle may have a velocity and hence a momentum. So the system as a whole may have a momentum p, which may be simply given by the vector sum of the moments of the individual particles. I hope you people are understanding the concept. Concept is very, very, very important. So if you understand the concept, everything will be very easy to study. So try to grab the concept more. Okay. So here we are going to find the particles, that is P bar is nothing but a vector where it is having both magnitude as well as direction. So we are taking the particles P1, P2, P3, so on Pn, or we can write it as P bar is nothing but we know that mass and velocity. So M1, M2, M3, V1, V2, V3, so on M1, Vn. We can write this or that. As per the definition, the velocity of the center of the mass of the system of the particles given by. So these equations are being taken. These are the assumptions which we have taken and we are trying to simplify it. Okay, as per the definition, the velocity of the center of the mass of the system of particles given by V bar centimeter is equals to sigma mi vi bar by sigma mi. So this can be written as sigma mi vi bar by f. So we have P bar is nothing but particle that is equals to mass or velocity by center mass. Okay, scale is nothing but center mass. Okay. So the above equation indicates that the total linear momentum of the system of particles is equal to the product of the total mass of the system and the velocity of its center of mass. Cm is nothing but center of mass. If f of E represents the resultant external force, E is nothing but external force acting on the system. So external force is nothing but we are giving some external outside. So inside also it happens. Inside also it conducts. If I'm giving some external force only, it starts conducting, right? So F bar of E is nothing but external force, that is M of A, that is center. Cm is nothing but center of mass. So comparing equations 3 and equation, 6 and 7, we can write F external, F of ext is nothing but external, that is equals to dp by dt, that is particle. Clear? This is the simplification how we are taking for the particle mass and the velocity and center of the mass. So now we understood the concept, how this collision takes place, how this linear momentum takes place. So now conservation of linear momentum. First we have studied about one single particle. Next we have studied about a number of particles. Okay, system of particles. Now conservation of linear momentum. What is mean by conservation? Please tell me, anybody.
Conservation means it will be always the same.
What?
Conservation of
Conservation.
Conservation means it will conserve the amount, means it will keep it like that only. It will not change for the time with the time.
Okay. Yeah, correct. In physics terminology, what we can say?
Physics.
So we need to talk in physics. The conservation, as you told, no, sorry, as you told, the careful we are going to maintain. Okay, the natural process to prevent it for disappearing. So we are going to conservation of energy, conservation of water, uh, sources, whatever we have now. We try to protect that natural resources. Okay, is a
Yeah.
physical supply of something that exists in nature, such as soil, water, air, plants, animals, and energy. So we are going to carefully maintain all that. If we destroy all that, we are not going to be useful. So conservation, general meaning is nothing but a natural resources, which is a physical supply of something which is exist in our nature. That might be soil, water, air, plants, animals, and energy, etc. Whatever. So we are talking in physics terminology. So we need to understand how this is useful in the conservation of linear momentum. Okay, so conservation of now we understood the main concept as your good name, Vinod, right?
Vinod.
Yeah, as Vinod said, what is conservation? As he told, it's correct. Okay, now you try to explain how can we this will be useful in physics terminology. Anybody? Anybody? It should be like interaction. So what it states is nothing but, so what is conservation? We know that. So that might be energy, fuel, gas, plants, animals, everything is a conservation. Okay. So in particular measurable property of an isolated system does not change as a system evolves over time. We can talk this as in physics terminology. Okay. So in physics terminology, we can say that something which does not change. It does not change. Okay. Something which does not change is nothing but conservation in physics. Okay. For example, if I'm taking some, what can I give the best example is uh,
We can take it example as an energy. Only it gets distributed to others, but it will not get diminished.
it cannot change. See, something
Yeah.
which does not change. So we can take an equation which represents a conserved quantity is constant over time. Okay, it has same values both before and after an event. So if I'm taking, for example, the energy can be distributed. See, energy means, for example, if a fuel is there, we have made the fuel and we are using, no, we are using it. So the energy which does not change is nothing but a conservation in physics. So let us talk conservation of linear momentum. So now we understand what is conservation, which does not change. It will be remaining the same. So for example, if I am giving some external force, okay, the energy is being transmitted, but still it remains the same. Okay. So in simple terms, what we can say that a certain physical properties that is a measurable quantity does not change the course of a time within an isolated physical system. So we call that in a classical physics or momentum or angular momentum, mass and electric charge. So if electric charge, what happens? If I'm giving some electric charge, it continuously produces. It does not change. It continuously flows. So we can take an example that is a that is kinetic energy also we can take. Potential energy is converted into kinetic energy. So the conservation energy in physics we can give the example is nothing but if I'm taking a slope, okay, which is a potential energy, is converted into an kinetic energy. So when friction slows the When a friction slows the clock to a stop, the kinetic energy is converted into thermal energy. So this energy can be converted. See, for example, we can convert so many energies into one energy to into another energy. So where that position will be the same, but we are taking it as an, so from water also we are converting into a what energy? Tell me. We are taking some energies, right, from the resources. The energy which is being converted. But that will be remaining same. Water will be like water, but from that water we are taking power, no? We are taking the power. We are converting into the power energy.
Electric,
So,
hydraulic
yeah,
power.
yes. So we are using that. So water energy will be like water energy, but we are converting the change that which we are going to be used. So like that, so many energies. So from petroleum, the solid materials which we are converting into petrol and we are using as a fuel. The energy is converted, but the material will be the same. You got my point why I'm explaining so much, because if you understand this conservation of linear momentum, everything will be easy in this topic.
Yes,
Okay.
madam. Understood.
Okay. Got it now? Shall I go a little further? Okay. So if the sum of the external forces acting on the system is zero, that is P bar by dt, that is equals to zero. So P bar is nothing but particle will be constant. This result indicates that when the sum of the external forces acting on a system is zero, then the total linear momentum of the system remains unchanged. This result is termed as a conservation of linear momentum. So why we are talking about this is to use for the next and next step. So the principle of conservation of linear momentum has a wide range of applications and is important in study of many collision, process and interaction. This law is considered to be the cornerstone in the study of interactions in the realm of both classical and quantum mechanics. So what is quantum mechanics? We have next semester. So I hope you know what is quantum. Quantum means very, 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 very small. Okay. So for that also we are going to study. That is your next semester topics, quantum mechanics. So the law of conservation of momentum is so basic that it's worthwhile to state it in several forms. Namely, the total momentum of an isolated system is constant. When a body transfers momentum to a second body in collision, the loss of momentum of one body is balanced by the gain of momentum in the other. So why we are combining both linear momentum and collision? Because when the conservation of a momentum, linear momentum, which is a solid body. Okay. So the solid, which is converted into liquids, how it is being converted because of the collision is taking place. Then only it is becoming a fuel, or then only it is coming into an energy. So we are taking from water molecules to the electrical energy, power energy. You are understanding, right? Why we are talking or why we are studying about this linear momentum and collision. From solid body to we are converting into liquid. From liquid body to also we are able to convert into a solid body. So for example, if I'm taking a coal, which is helping to produce some heat. So how heat is being producing? Because of the collision. So energy is being transmitted. So from liquid to solid, solids to liquids. That will be studied in your thermal energy in your next semester. Got it right?
Yes, madam.
It's right? Okay, good.
Yeah.
So then any doubts here? Nothing, right? I'm clear. Everybody? Anybody, if you have doubts, please raise your voice and ask me.
As of now, no doubt.
Okay, clear. Then let us move little further, little how this collision takes place and how the conservation of momentum is taking place. So here you can see the projectile motion of bombshell. Okay, how it flows somewhere and it bursts somewhere, right? So this is a projectile motion of a bombshell they have given. So next topic will be the impact parameters. You just please go through this. See, if I read line by line, if I never explain, it takes completely more than 2 to 3 hours. So just go through it. It will be easy how this conservation, because I have explained how this conservation of linear momentum takes place. So how it is being converting from solids to liquids or liquids to solids, right? We are able to use it in both the ways. That's why linear momentum and collision we are talking. So what is impact parameter? How it takes place? Why it is going to be used? Where we are going to use it? So in the carom board game, before starting the coins will be placed at the center of the board. When coins are hit by the striker, the path of an they are just giving the example to understand what is the impact. Impact, as I told you, it impacts the whole body. Okay. See, the best example they have given a carom board where you are going to place all the coins and the striker, which is a hit, all the coins will be placing somewhere else, right? So the striker, the path of at least one of the coins or many at the time suddenly changes at the center. Center place is being disturbed. So in this short interval of time, huge force is applied on the coins. The time of response to the striker with the coins will be very less than the time to observe the motion of the coin. So how this impact is happening for that position or that place. Okay. So in Rutherford alpha particle scattering experiment, alpha particles never directly hit the nucleus. Yes. Okay, of a gold foil, but while approaches the nucleus of gold, they experience a Coulombic repulsive force, hence the path of the particle, alpha particles will be changed. This is an example of nuclear collision, how this nuclear collision takes place. Collisions in which conservation of momentum and energy holds good is called elastic collision. The collisions in which only conservation of momentum holds good but not energy is called inelastic collision. So different types of collisions we have. So some may hit, some may does not hit. So how and when, that is what they have studied much in depth. So in order to explain the Rutherford alpha scattering experiments and all the same of the scattering experiments, one need to know about terms like impact parameters and scattering cross section. Scattering means what? The light is being scattered. Okay, so we need to talk scattering. So when a light falls on any material, what scatters? Photons will be scattering. The light is being spreading, right? So with which energy? With the electrons. The electrons are the glass material which is being having, which spreads. So whatever the light we are observing, that is nothing but scattering. Means the light is being scattering. Okay. So here we can see actual path and deviate path. Okay. So when a particle, normally what we see through our eyes, it may be the actual path, but undeviated path. It can hit and it can flow in this way. Okay, this is what they have observed. Let us consider a nucleus N. Here the nucleus N, where alpha particle approaches the nucleus, it moves under the influence of Coulombic repulsive force and traces hyperbolic path. Okay, if the nucleus is not there, the particle would move in the same direction, which the previous directions in which it was moving. Draw a perpendicular from N nucleus, okay, perpendicular to the N nucleus on the line along with an alpha particle is moving. So the perpendicular was moving. So the perpendicular distance between the nucleus to the initial directions of the particle is called impact parameter. So how the impact parameter is taking place. Normally we will think that it will be moving in this actual path, but the impact parameter is in this way, how the direction is taking place for the nucleus. It may go this direction or it may go this. See, this is an imaginary. Whatever the lines drawn was always an imaginary. Okay. So this is what is the impact parameter. Around 1 in 8,000 alpha particles were deflected by every large angle over 90 degrees. while the rest pass straight through the little or no diffraction. From this, Rutherford concludes that the majority of the mass was concentrated in the minute, positively charged region. The nucleus central charge is surrounded by electrons. There are large empty space in the material. Consequently, alpha particles pass through without its path getting affected. So this we will study much depth in your waves and optics. Okay, how this wave is transmitting, how this light is being scattering, how which electrostatic materials are going to be used, and all this is like they have just given the direct how this impact parameters takes place. Now we just need to understand how this is impacting. As the good example, if see, they have taken number of particles that is here on the carom board. So if a particle is hitting, so all it distracts. The impact factor is happening in all the particles. So that is what they are explaining in different ways how it can be happened. So when a positive alpha particle approached sufficiently close to the nucleus, it was repelled strongly enough to rebound at high angles. Same size of the nucleus explain the same number of alpha particles that were repelled in this way. So for example, if I am taking, so let me explain you with an example. Atom is there, okay, surrounded with a nucleus, uh, and you have electrons. Outermost shells will be electrons. Okay, so when light passes on one atom, so what happens? The energy which will be transmitted will be traveled to the out near to that shell. Understanding, you please try to imagine if an electron, okay, let us take a one single electron. So one electron is there, another electron is there, another electron is there, continuous electrons are there. So when a scattering of a light means a light is fall on an electron. So what it does normally, it starts vibrating and energy will be re-radiating. So electron will not jump from one shell to another shell. The energy will be transmitted. Okay. So in liquid state, it does not happen. It collides. It keep on collides. So in solid state, what happens? It does not move from one place to another place, but the energy will be transmitted. That will be also in a wave. So in previous class, I told you how the waves are being affecting everywhere. There will be a wave, whatever the particle or whatever we are talking, everything will be moving in a wave. Okay, so how this energy is being colliding, how this energy is being transmitting, that is what they are explaining as the impact parameter. So impact parameter is nothing but it does not go and hit all the time. Okay, so striker is there, striker hit the different points, so different points are elaborating here and there or scattered somewhere here and there. But some particles, what it does, light is there. Light falls on an electron, okay, or any material. Okay, what happens? It starts vibrating and re-radiating. The energy will be transmitted from one place to another place. So this is what they experimentally they have done in different. So the research process will be continuously happening. The examination takes place. Experiments will be done. Still, everything goes on, right? We are inventing, keep on inventing new things. There is nothing that this is done. There is end. There is no end. We are keep on inventing, no? So many different things. So in
Yes,
such a
madam.
way, yeah, in such a way, how this collision takes place, how this linear momentum is taking place, how this impact factor is taking place, that is what we are keep on studying. So we are just studying only the basis. Please remember that we are not studying something rocket science, simple basics physics. So how this collision is with the cross section. So how this cross section takes place. Okay, see for example, X is there, Y is there, Z is there. So it passes through the X, it touches Y, or it may touch through Z. So collision cross section, it may be have a cross section. So when a light passes on X-ray, so it can touch Y as well as Z also. So before we go into estimate the cross section for atomic collision, let us interaction between macroscopic particles. Macro means very small. Okay, and estimate the corresponding collision cross section. Consider random firing of a bullet from a machine gun onto a bar, where a number of plates of area sigma are hung in a random manner. Relate the number of plates Pn and the rate at which bullet strikes a bar Er. The rate at which the plates are broken is given by. So here they have given the how this collision cross section takes place. So can be determined by measuring R, A, and R naught. Just go through this. You'll understand what is cross section. Collision cross section application to an atomic collision. So atomic collision means how this atomic collision takes place. So in nuclear physics, we generally have situations where the target materials are bombarded by nuclear particles and accelerated to high energies in order to study the particles interaction or reaction process. By measuring the rate at which a particular event takes place in the cross section for that particular event may be assigned. For example, let us consider a thin foil of aluminum, okay, bombarded by neutrons. Many events may take place depending upon the factor like energy. These events may be one, elastic scattering of neutrons into the forward hemisphere, elastic scattering of the neutrons into the backward hemisphere, inelastic scattering of neutron between the angle 30 and 60 with the directions of the incident beam. So the nuclear reactions of the type. So these are the different types of the nuclear reaction, how it is taking place with different materials. You can take with the magnesium, aluminum, and silicon, helium. Okay, different materials also you can find the cross section. So where you are called the cross sections for elastic scattering, cross sections for inelastic scattering. So elastic means which can travel. Inelastic means it does not. It will be in the same position. Cross section for absorption and cross section for particular type of nuclear reactors. To determine the cross section experimentally, usually the number of events for a given kind is counted. The cross section for a particular process is determined using the collision cross section corresponding to the effect of all possible processes called the total cross section. It's told by the sum of the constituents for all the possible reactions. So how it is reacting, how it is taking place, how this reaction takes place, how this can be calculated by obtaining the radius of the nucleus can be expressed and the mass can be expressed and intermediate mass can also be expressed by the nuclear reactions. How these nuclear reactions can be taken place. So different calculations can be done to find out the mass, intermediate mass, and the nucleus. Okay. Cross sections, rough estimated magnitude by Kelvin. Okay. You please go through it. It's simple. You can understand. There is nothing complicated to understand all this. How this cross
Madam,
section. Yeah.
here it is mentioned that
Mm-hmm.
this equation number 3.17 sigma is
Okay.
equal to
Mm.
0.95 10 to the power 28 meter square and 0.95 burns. What mean by these burns? Yeah,
BARNS, this one.
yeah,
So they are
yeah,
giving some name to find out that. Okay. In nuclear physics, if we go depth into the nuclear physics, we can understand. So they're just giving, see, this is for 0.95 barns, BARNS. They are
yeah.
calculating in that values. Okay. So just naming to find out. Okay. Barns
So,
is, hmm,
so what we can say, actually earlier it is, there is a question, what is the unit of cross section? So
hmm.
what will be the unit of cross section?
Unit of,
Cross
Unit of
section.
cross section is one barn.
yeah.
One barn is equals to 10 to the power of 28
See,
meters square.
so here, what we are taking, we are just finding for one unit. We are able to find for mass. We are able to find for internal mass. We're just calculating. Okay, here they have given no. So a rough estimation. It's a rough estimation. They're not talking about it. See, in physics, we can't find the accurate value. All the time, we will talk about approximate because it's an
Okay.
imaginary world. It's an imaginary. We need to imagine and we need to see this. This is the imaginary. things what we imagine and what we are going to calculate with the mathematics. Understand? So that's why a rough estimation they have given. They have not said that a accurate estimation, right? A rough estimation of the cross section for nuclear reactions can be obtained. Can be obtained. They're not giving you an accurate value. So the radius of the nucleus can be expressed as can be expressed. We can express. So I have done some experimental. I am thinking that this is the equation I can express in this way. If you are doing it in an experimental way, then only you can say that it is an accurate value. So I am imagining I have done some research work. I am assuming I am giving you some estimation. This is a expression. Okay, so R is equals to 1.18 to the power of 1 by 3 10 to the power minus 2 meters. So where A is nothing but a mass number. So I'm getting the second equation. So I'm taking that A value and hence I'm going to find the Barn value. So this is nothing but a cross section as a target area and to get a rough estimation of its magnitude by calculating the geometrical cross section. Okay. So it is not a C. It will not represent the true meaning of cross section pertaining to a nuclear reaction process. So we are assuming that we are doing. Got it?
Got it. Got it.
Okay. Good.
Yeah.
So please ask, no problem. So it will be more clear to understand. So we are all the time, whatever we do, the experimental or whatever we are studying, that is like approximate values. We can't get as electronics on and off, switch on and off. We are not getting any proper appropriate values. We will assume first. We are thinking. See, physics is nothing but we need to assume. So neutrons, electrons, protons can't be seen through our eyes, right? It cannot be seen. So they have assumed, so this is happening in this nature. So with this particle or, so if I want to find for n number of particles, I need to definitely calculate for one single particle. So that's why what we have studied for one single particle, then system of the particle, then next to the linear momentum of the particles, then collision. How this collision is taking place, it might be in solids and it might be liquids. It can be converted in any energy, right? We can convert. So that conservation of energy will be the remaining same. Yes or no? It will be remaining the same, but from that which we are converting from one energy to another energy. However, we want to use it, we are digging and we are taking that material out and we are converting into the solids to liquids, liquids to solids. Got it? So further we are going to study the nuclear physics. So nuclear physics is a vast subject. In your degree level you don't have. So nuclear physics means you have to immerse into the nuclear point of the atoms and nucleus, how this is reacting, how this collision is taking place, when energy is being transmitted, how it is immersing and how the energy is being getting out. This is like a complete research. It goes on and we can study completely all the time. Okay, so you please go
Yeah.
through, you please go through this. It will be easy. There is nothing complicated. If you understand the concept, it is nothing complicated. You please go through it because we have only 1 hour time to discuss. Every day, if we have class, that will be more elaborately I can explain. But we have only 1 hour class only on Sunday. So I need to complete according to your syllabus. So I just want
Okay.
to cover all the syllabus.
Yeah.
Okay. Okay, see here you can see the how the radiation is taking place for the cross-sectional or valuable for the nuclear data. They are just finding out the cross-section versus energy of neutron being targeted being cadmium. So we have taken some material and we are just finding how this like this we can do so many experimentals. So ultimately, what is the graph or the energy, how it is being transmitted for one material to material, it changes. See, if I'm taking lithium, a light is passing on a lithium will be reacting in different way. If I'm taking niobate, it will be flowing in different way. Oxygen, if I'm taking different way. Carbon dioxide. So I can find out for the all different materials and I can do the experimental value and I can give the assumption. So theoretically, I'm telling, not experimentally. Theoretically, I'm telling that this may happen. Experimental, if you want to do, you can do it and you can get a proper values. Okay, so this is about the summary also they have given. Check your progress answer, work on examples. So this is about your third unit done. So next class we will do some more much better of your we need time. See, yesterday I missed the class. But we might be completed your fourth unit also. Kinematics. Okay, so next class, what you people to need to do before coming to the class? So I want you people to know what is kinematics, how this rotational movement takes place, and how this angular velocity and the acceleration. So this further, why we are talking, we have studied about linear momentum and collisions. Now we are going to study about a rigid body. So I told you what is rigid. So what is kinematics? What is rotational motion? What is rotational kinematics? This all we will discuss in your next class. So with the unit, we'll complete 4 units. Next class, we can complete another unit also. Next, then how many units are there? Unit 5.
12, ma'am.
How many?
12, ma'am.
12 chapters completely.
Yes, ma'am.
Okay. So till how many days you have classes? You please create some group.
I
Okay.
think we have only two more classes.
Hmm. See how how can we complete that? Okay, create some group. What I can do, how much we complete, we complete. Later on, I'll help you out.
Madam, I have created a group for the BSc.
Hmm.
Uh, if you
I've
share the number, I will
yeah,
add you.
just now
And
I have shared the number. Please take it down. That's only my WhatsApp number. You create a group. If you have any doubts, you can ask me. So I'll let you.
yeah,
Okay. Okay.
yes.
Okay. See you all in the next class.
Please share the number, madam. Okay, yeah.
Feeling for electricity.